So inequalities are this classic, I don't want to say weak spot, but maybe I'll just say weak spot. It's one of those skills that everybody, I think, could benefit with some more practice on. If you want to find our instructional videos for each of these 30 topics, you can jump into the Alex menu, go down to the tab that says Instructor Resources, right down here inside of Alex. And then it'll say Goal Topic Explainers. Just click on through. Yes, continue. And it's got each of our 30 topics listed in this big array. It has some outdated due dates, so don't pay any attention to these. But the topic that we're about to look at from the inequalities section is the topic of solving linear inequalities with several occurrences of the variable. So on this page, if you click on that, it'll take you to an animated solution. Animated GIFs may be broken, but the links that they correlate to still work. So if you just click on this empty box, it'll take you out to YouTube. Linear inequalities may be solved using all the same steps that we use to solve a linear equation. Yada yada, right? So some dude with an obnoxious voice telling you how to do this. So yeah, do use the Goal Topic Explainers. Are a great resource for specifically, again, honing in on those 30 topics that are going to show up on the exam. So let's go back to the problem from the practice problems that we were just working. And let's try and make some peace with it. So we have to solve this inequality, get the y by itself. We got some fractions. We got the variable occurring on both sides. So what do you want to do to start out the process? What's a good first strategy? Maybe to tackle the fractions problem first. What can we do? Okay, so we could get all the like terms onto one side. I might do that by subtracting the 6y from both sides. And then maybe I'll also add 3/2. Maybe I'll just work on the y's for a minute. So that what I'll have here is 5/8 y minus 6y minus 1 is greater than negative 3/2. Okay, so now my like terms are on one side. And at this point, I could actually combine these two like terms, but that would require me to do fraction arithmetic that I'd prefer not to do. It's kind of late on a Monday at the end of the semester for me to think about common denominators. So what's my alternative? If I don't want to actually subtract those fractions, what can I do to just nuke them for more bits? Yeah, exactly. Again, probably the most underrated technique in algebra is to wipe out all the denominators by multiplying both sides of the equation by a sufficiently composite multiplier. Something that is a common multiple of both 2 and 8. Because if I do that, then everything with a 2 or an 8 in its denominator is no longer going to be there after we carry out this multiplication. So what's a common multiple of both 2 and 8 that I can use here?
2.
So 2 is a common factor of both 2 and 8. So it doesn't have quite enough juice to get rid of the 8, but it certainly could get rid of the 2. 16 would do it. That has enough juice to get rid of the 8 and to get rid of the 2. But it's actually too much firepower. We could use 8. 8 is the smallest of the common multiples of 2 and 8. It has enough juice to get rid of this 8 and to get rid of the 2, and just enough, and no more. So the benefit of using the least common multiple is it's going to give me the smallest numbers, smallest coefficients after I carry out this multiplication. So when I multiply 8 by 5/8, I'm going to get 5. I multiply 8 by 6, I'm going to get 48. I multiply 8 by negative 1, I'm going to get negative 8. Multiply 8 by negative 3/2, and that's the same as, remember my little trick of taking the denominator of this fraction and moving it from the 3 over to the 8 instead. Just slide it on over, because multiplication is commutative, we can do that. So that what I end up with is 8 over 2 times negative 3. 8 over 2 is better known as 4. And 4 times negative 3, negative 12. So now all my fractions are gone. What happens with this greater than sign? Should I keep it or should I flip it? keep it. How do we know when to keep it?
You didn't divide by negative.
I didn't multiply or divide by a negative number. I multiplied by a positive 8. So we're going to keep it. Great, and now all of our fractions are gone. We did the step of getting all the y's onto one side already, so all my y's are on one side. And so now this just becomes the kind of inequality that we like to solve, which just requires us to combine these like terms. 48 and 8 come together to give me a 56. Whoops, I forgot a y. That was close. 5y minus 48y, that changes things. Negative 43y minus 8 greater than negative 12. We'll add 8 to both sides. Negative 43y greater than negative 4. And then what's my last step? Divide both sides by negative 43. But when I divide both sides by negative 43, I'm going to ask again, should I keep this inequality or flip this inequality? Flip it, because we divided by a negative. And then a negative divided by a negative can be easily rewritten as a positive. And so the solution that I get for this inequality is that y is less than 4 over 43. So what do you feel like was the stickiest step in this process? I have my guesses, but what do you think? A related problem was the next problem. Uh-oh. Sorry. So on this absolute value problem, one of the common strategic errors that people make on these problems is trying to split apart the absolute value too soon. So I'm not going to do this whole problem, but I will just mention that before we can split apart the absolute value, and when we do that, right, we get one side where the inequality stays the same, and so does the right-hand side, and the other one, the inequality flips, and the right-hand side is turned into its opposite. And then in this example, well, I guess we'll see when we get there, we have to decide on the logical connective, the and or the or that we get. But before we can do that split, we need to get the absolute value by itself. And so the first step is not to split, but the first step is to add 5 on both sides. And from there to divide by 4 on both sides. And you end up with absolute value of x minus 9 is less than or equal to 4. And that, then, is the time you can split. So absolute value is by itself. Then we can divide it up. And when we divide it up, the first of these two inequalities, we just get x minus 9 and 4. Right? We keep the thing inside, and we keep the right-hand side and the inequality symbol the same. And in the other version, we keep x minus 9 the same, but we flip the 4 to a negative 4, and we also flip the inequality symbol to the other way around. And because this was a less than or equal to in our original absolute value inequality, the connective that we put here is and. And then from there it becomes a compound inequality problem. But yeah, don't try to split apart the absolute value too soon. Do some algebra first to unwrap it so the absolute value is alone before you then split.